Let's look at number 8 in section 3.2. In number 8, we're to compute f prime, which is the derivative of the function f, and then we're going to find an equation of the tangent line to the graph of the function f, that is, at x equal a. And here's our function. F of x is 12 times x to the negative 3 power. And then we're doing it at x equal a, so at x equal 5, a is 5. Okay, so in order to do that, we, of course, hopefully know by now the tangent line, its slope is equal to the derivative of the function at that point. So I'm going to need the derivative of this function. It doesn't say anywhere in here about using the limit definition for the derivative, so I'm good to just use our shortcut rules. And I'm going to use a couple rules. First of all, 12 is a constant multiple of x to the negative 3, so I can pull that 12 out. And then I take the derivative of x to the negative 3 with the power rule, bring the negative 3 down, x to the subtract 1 from negative 3, negative 4. 12 times negative 3 is negative 36, x to the negative 4. And this is a fine answer in this case. They don't say to put it in fraction form for f prime, but if you want to write it in fraction form, which is important because the equation line, they would want you to give exact values for the coefficients and in the equation. And so I'm going to rewrite this in fraction form. X to the negative 4 is 1 over x to the 4th. So this can also be written as the derivative. Okay, so now what's the slope? The slope is going to be, of course, at x equal a, x equal 5. So I'm going to find the slope by computing this derivative at 5. So I replace x with 5. 5 to the 4th turns out to be 625. And so I get negative 36 over 625. This fraction cannot be reduced any further, since notice 36 is 6 squared, or 2 squared times 3 squared. So there's no common factors with 5. Okay, so there's your slope. Now, what's the point that we pass through? The point of tangency is this point where, again, it's at x equal 5. So 5 comma f of 5. So now I just go back to the original function and plug in 5 into it. Of course, 5 to the negative 3 power, 12 times 5 to the negative 3 power will be 12 divided by 5 cubed, right? 5 cubed is 125. So there is the y value. So now I just plug into my point slope form. My point is x1, y1. My slope is m. So I plug in y1, which I just computed here, my slope here, and then x1 is 5. And now I just need to solve for y. I distribute this through this big ugly fraction. Looks kind of unwieldy, but it's a nice number. Multiply by x, I just get this. Now when I multiply the negative 36 over 625 times the negative 5, notice negative times negative gives me positive. And this 5, there's a factor of 5, right? Remember 625 was 5 to the 4th power. Well, I can cancel, when I multiply, I can divide numerator and denominator by 5, and I'm just left with 125 in the denominator. Hopefully that makes sense. So I'll get positive 36 over 125. And then to solve for y, I add 12 over 125. Notice they have the same denominator, so I can combine them, and I get 48 over 125 for the, that'll be the y-intercept for my tangent line. So there is the equation of the tangent line in this case. All right, hope these problems are making sense to you. As always, come see me for help, or contact me for help.